Hello, everybody. Good morning or good afternoon, wherever you are. Thanks for joining this webinar today. My name is Elham Gabuli. I'm the product manager of RhinoLands, and today I'm going to present you the first part of this webinar, which is a general overview of the program. Then my colleague Francisco Saya, who is now available here,
Hello.
will continue with the live demo. Okay. RhinoLands is a BIM standalone program for landscape architects. The program specifically is designed and developed for landscape architecture and urban planning. So when we call it a standalone, it's because it already includes Rhino 8 inside the program. So the first part is the general overview of the program. And let's see how is the program and which are the key features of the program. The program is a BIM program, meaning that it provides technical drawing. The 2D and 3D are linked together, so we will get the 3D model at the same moment. It automatically generates the list of plants and other materials which are used during the design process. And there are several tools for visualization of the project. The program is standalone. It includes already Rhino 8, and with the next versions of Rhino, it will get updated as well. The program is developed here in Asuni with the same company group of McNeil Europe, and well, from here we are also developing some plugins and some other softwares like RhinoLands at this moment. As you see, the interface of the program includes a selection of drawing and modeling features, the most important commands of drawing and modeling, and then the generating terrain, vegetation and hardscape, irrigation, documentation, and there are some tools for visualization, including Rhino render as well. The program is used for landscape architecture, as I mentioned, but also it is used for green infrastructure design by civil engineers, urban planning projects, and for environmental projects. For example, we can easily model a forest by using the program. Let's see its main features. First of all, the program includes an extensive plant database with more than 8,000 plant species. The plant database includes several filters to select the adequate plants based on climate type, soil type, different characteristics like aesthetics, like flower color or so on, that you can see here. Also, the same plant species has several blocks, different blocks that are going to be used in different presentations. There are different ways to visualize the plants, and there are different display modes that you see. We can visualize them in conceptual, elevation, or realistic form. In realistic, we have the access to seasonal representation of plant species. So in this way, we will visualize our landscape in different periods of the year. And we can compare the seasonal change of our landscape design. 2D and 3D are linked together. We can switch between them at any moment. And as you see in 2D, there are specific blocks that are going to be used in 2D. Also, there are different hatches and different 2D drawing tools. We can insert plants in different ways. We can insert them individually. We can insert them like a row of plants, or by using the paint mode, we can paint them actually by moving the mouse on the plot. We can convert points to plant species, or we can convert any kind of blocks like AutoCAD blocks to a 3D realistic plant species inside the program just by one click. We can insert a row of plants by indicating the distance and the combination of plants, or insert a group of plants, again, by indicating the arrangement, the plant combination, and so on. In the similar way, we insert shrubs by indicating the units per square meter or per linear meter, or in imperial system as well. Inside of plant database, there is an access to an add-on, which is a plant editor. So we can edit a 3D realistic model of an existing plant species. For example, we can change the branches, any kind of structure of this plant model. We have powerful terrain modeling tools that help us to generate a terrain by points or lines or combination of them. Once the terrain is generated, we can easily modify and generate different types of cut and fills, create a path, or divide the terrain. And the program will generate the list of quantity of earth moving operation. We can insert a terrain just by indicating the location on the map or by converting a DEM file, by importing a DEM file, digital elevation model. In this way, by using terrain tools, we can compare different alternatives of the same project and select the more sustainable project or more suitable alternative. As you see, we have two alternatives for this example. So we can compare the result of field volume and big volume of this terrain operation and compare which project would be the best alternative. There are dynamic documentation tools that help us to generate different documentation of the same project. So we have labels, which generates the label of plant and the quantity of them in each group or in each species that we select. We can add the image of plant species by using the specific command for that. And in similar way, we can generate different types of plans and dimensional plans or detail of dimension. We can also generate different sections and different layouts as well. There's a layout manager, for example, inside the program that helps us to manage our layouts and by turning on and off the layers as well. There are hardscape tools that are basically parametric, all of them. So we can generate ramps or stairs and modify them easily by from the edit panel. Can you please mute? Yeah. Thank you. Well, so there are also parametric fences, and there's a block library of furniture inside the program. But in addition, you can import any kind of blocks that are compatible with Rhino, for example, SketchUp blocks or DWG files. There are some tools for irrigation design that help us to design the piping and the sprinkler list. We can insert them in an array mode in a matrix, or we can insert them individually, and the program will list the quantity of pipes and sprinklers at the end. For visualization, we have walk mode. We can walk through the project by using the walk command, walk tool. We have sun and shadow visualization that you see here. So you indicate the location of the north and the location of the project in the board, and you can see that how the shadow is moving during the daytime in different periods of the year. Also, there's a render possibility, which is Rhino render, the internal render of the program. But in addition, you can apply any other render. Also, there is an image filter inside the program. So this is the result of the internal render engine of the program, the Rhino render. So without applying any external Rhino rendering engine, you can achieve this kind of photorealistic result. But these are also the examples of the connection to other rendering engines like Enscape, Twinmotion, V-Ray, and Lumion. It is totally compatible with these programs. The animation that you see here is a project that is made by using RhinoLands, and the animation is made by using Enscape in this example. So in this way, we can bring our ideas to life. Another feature is that the program includes parametric design feature. So we can apply Grasshopper. In the case of Rhino, the parametric tool is Grasshopper. So we can apply Grasshopper to generate a geometry from algorithms, or we can apply Grasshopper to link an external data to a BIM geometry inside the program. and do different types of analysis. We will see an example. These are the components of Grasshopper, but this is for an advanced level. Just in case that you are familiar with parametric design, you can study that later. This is an example of what we can achieve by using Grasshopper. We are going to insert a bunch of plants and then in different size, and then by applying a kind of definition, Grasshopper definition, we are going to place plant pots with the same diameter of these plant species. These plant pots are linked to plants, so if you move the plant, and they are also going to be to move and to be placed again around the plant. This is just a simple example, but we can imagine that if you know Grasshopper, you will have an unlimited possibility of automating the design process. Well, so another use of a connection to Grasshopper and applying Grasshopper actually is that we can link we can do environmental analysis. So we can link external data through Grasshopper to a BIM geometry and do different types of analysis. For example, we have published the calculation of carbon. So after designing this project, you can calculate how much carbon will get sequestrated by implementing this project in different periods of time, in 10 years, in 20 years, and so on. We can calculate the cooling effect of plants on the floor, so the impact of shadow on the floor. We can do shadow analysis by applying Grasshopper. For example, we can calculate how much percentage of the floor is covered by the shadow during the daytime and during different hours of the day. Also, we can calculate solar radiations by connecting the program to Ladybug, which is Ladybug tools, which are free access programs through Grasshopper. So this is an example of how we can calculate carbon sequestration. You can see that we have a model, a landscape model in RhinoLands, and on the right side, we will see that this is the carbon calculator that we have published right now. So this is available right now. So by applying, by linking this model to the carbon calculator, we will see that how much carbon will get sequestrated by implementing this project. So we indicate the age of plant species at the beginning of the calculation, and then we mark that in 10 years or in 20 years or in whatever period of time, how much carbon will get sequestrated. As you see, then the total number is calculated here, and also we can save it, and we can also show a graph of carbon sequestration of different species during this period. Okay, so another feature is that the BIM workflow from this program to other BIM programs. So in case of Revit, as you see here, there are definitions that we copy and paste them, and in this way we are able to import the RhinoLands model inside Revit, and Revit will recognize these objects as BIM objects with all its parameters. Another feature also regarding the BIM workflow is that we support IFC file format, so we can import or export IFC files. So let's see how is the design process with the program. If we have some topographic contours, we can generate a terrain by elevating these contours and generating a terrain easily. If we don't have any topographic information, we can import it from the map. So you open the importer, EarthScan, and generate the terrain. Once the terrain is generated, we can apply different operations on that. So we can do different cut and fill or divisions on top of this terrain. In continue, we add hardscape objects like walls, stairs, fences, which are parametric as well. So we can, for example, change the parameters of the fence, and stairs in similar way. So there are parametric. And let's see. Well, by continuing the design process, we can add furniture, so we can access to the block library of the program. Or if you have other blocks from different providers. You can import those blocks from SketchUp file format or Rhino file format. And we continue the design process by applying vegetation. So we can see that we can import different plants from plant database. We change the age of plant and the size of plant, and produce a different arrangement of plant species, for example, in the case of this group of plants. And then there are documentation tools. So we add labels of plant species, for example, the initials of the name of plants, and we can add image of plants as well. And insert the list of plants, walls, furniture, insert the different lists. And if you switch to 3D realistic, you can see the seasonal change of your landscape as well. Finally, we apply a render, and we will see how would be the final result in a photorealistic appearance. So let's see how is the workflow. Basically, if the program includes everything from base to trace. So you can start from technical drawing until 3D and documentation. But in case that you have a drawing that comes from any other CAD programs, like for example AutoCAD, or if it comes from SketchUp, you can open that model or that drawing inside the program and continue working on it. If you have geographic files like GIS files or digital elevation models or LiDAR point clouds, you can open these point clouds inside the program and generate a terrain based on that. For visualization at the end, you can shot a render by applying Enscape, V-Ray, Twinmotion, or Lumion, or you can use a virtual reality headset to visualize the project by using virtual reality technology, or print your project with a 3D printer. For documentation, you can export all these lists to Excel or to PDF, or you can just directly print your layouts that you have generated inside the program. You may have collaboration with other programs like import or export models or modify models from Revit, SketchUp, 3D Max, and so on. But so in summary, you can do the whole design project by RhinoLands. You can produce different plans, realistic results, and sections by using the program. This is a real-world application of RhinoLands in Madrid. This is a green infrastructure in Madrid that you see. There are there are many more layouts on the page of this project that are available on our website. And just to summarize, we have a 60-day free trial. You can try that at the end of this webinar. The licenses are permanent, but also we have the possibility of a monthly subscription. In case that you have tried the trial period before, you can just sign up for a monthly subscription just for a couple of months, for example. You will have free technical support from our team, and there are educational and lab licenses at a reduced price, so just check it out by yourself from our website. Do you have any questions up to now, or we can continue with the live demo by Francesca?
No questions.
Okay, yeah. So Francesca, you can continue.
All right. Thank you very much, Elham. I hope you can hear me well.
Yeah.
So basically, we will see what Elham has explained, but with a live demo. So we will have an overview of the main features through this live demo, so you will get the feeling of working with RhinoLands. Okay. First of all, I want to show you first the comparison between the RhinoLands interface with the Rhino regular interface and having land design on top of it. So as you can see here, this is Rhino with land design in a kind of a simplified interface. So we can find here all the 2D modeling tools in 2D, all the tools for modeling in 3D, okay, from the basic geometry to all the tools to work with this 3D geometry. Then we can find here terrain modeling tools, vegetation and hardscape elements, irrigation, documentation, okay, everything that we need to list the elements that we have in the project, also to annotate dimensions or work in page layout. So everything is available here. Then we can find some other tools for visualization, changing the display mode in the viewports or the viewport position. And finally, some additional tools to select objects by type. Then we can find here on the right side the edit panel, from where we will be able to edit everything that we select, but also we will be able to switch between the different display modes. Okay, and also we can find here other panels to see the properties of objects, to work with different layers, and so on. So just for you to compare, if we install Lands Design as a plugin, we'll have the regular Rhino interface and Lands Design here with the set of tools that are the same that are in the RhinoLands interface. Okay, but today I want to show you this demo based on this new interface. Okay. Now imagine in a typical situation where you may start by opening a DWG file. Okay, so RhinoLands supports many different file formats. So it's as simple as going to a file, open, and then selecting a DWG file. Okay. So RhinoLands, I mean, there is some import options. I click OK to just choose the default. And then we can see here different viewports. We have perspective, we have top, front, right. We can double click here to expand this view. And this is just a set of 2D curves. They are stored at different layers. So we can show and hide them, by switching each layer from these icons. We can control here the colors, the line type, the print width, print color, so on. And basically, this is how we could start a new project if somebody has shared, basic 2D lines, or we have created these lines directly from here. Well, I'm going to jump to this same project, but a little bit more advanced. So I've got it here, and we'll continue based on it. So the first thing I would like to show you is the different representation modes of the elements that we have in this project. When nothing is selected from this edit panel, we can see here that we have set the realistic display mode. We can change to detailed. Okay, there's another level of detail for plans in 3D. There is conceptual, which will show the conceptual shapes of these plant species, and also elevations that, in the case of the right or left viewport, can be more suitable. Keep in mind that these visualization modes are individual for each viewport. So we can have here the elevations, and here the realistic, or in 3D we can have also the realistic. And here in the top viewport we can see the project in 2D. Actually, all the elements have a double representation in 3D and in 2D. Okay, so when we work from the top viewport, maybe we can enable this 2D representation of plants, where they will show the 2D crown instead of the 3D model. Also, there are zones here that are displayed as a hatch pattern, and terrains, so I will show you in a moment, are displayed with contour lines. Okay. So, well, here you have an option to synchronize all viewports with the same representation mode. But basically, here you can select how you want to work in each viewport. Also, we can see here the list of all the plant species. We can select them from here. Okay, the plant species that will be highlighted here. And also, we can change the representation mode. Okay, we can browse here the plant library and select another file for this detailed representation, or we can assign another realistic file to that plant based on the files available in the library. There are over 600 or 700 here plant definitions that have this format, and these are definitions that can store different representation modes according to seasons. So when nothing is selected here, we can go to the document properties, okay, and well, here we can select in which season we want to show our design, or we want to shot a render. Okay, so those plans that then handle different representation modes according to seasons will show in one way or another. I select spring back, and now I can start inserting some plans here in my scene. Now, to insert a new plant, I'm going to go to vegetation and hardscape, select the plant command. In this example, I mean, in this document, there are already a few species that I have chosen before. They will be listed here. But if you want to insert a new species, just need to click on this browse button. The plant database will open. And here we just need to explore which plant species you want to insert based on these characteristics and botanical specifications. Just notice here that this number shows the number of plants that match with this criteria. So I'm gonna, well, select all the plants. And you can see here that there are over 8,000 different plant species. So as long as you are typing or selecting any of these criteria, you will see that the number of species drops down to according to the number that match with this criteria. I can click on this button to clear the selection. I can type here any plant by their botanical name or common names. For example, I can type here lemon tree if I want to insert a citrus lemon species. Also from this plant database, we can well, create new species. We can create it from scratch or copy an existing one, okay, and assign well, all these different 2D and 3D representations, fill up the form with all the technical specifications. So basically, you can expand the plant database with new species in the case that they are missing, okay? Well, in this case, I'm just going to select this lemon tree. Here, I need to specify all the dimensions, okay? That's something that you can change afterwards. And maybe we can click on this natural variation. Basically, if we insert several units of this plant, all of them will have some difference in height, okay? Also rotation, giving us the feeling that they, even though they use the same block definition, they are different from one to another. Okay, so I click OK, and I can insert my lemon tree here, maybe a couple of units. Okay. All right. I can select it. I will zoom in here. We can find some, useful tools to zoom in, zoom out, zoom to selected object. Okay, so it's easier to see it or orbit around it. And well, if we select now this plant, from the edit panel, we'll be able to change the properties of this object. So we can change the height. We can change the species. All right, so we'll find always the options available to edit these parametric objects that we select. Okay, we'll get back to the plant species later, but since there is here a big gap, I would like to show you now the terrain features. Okay, so here I already have a few contours. Okay, they are just 2D curves. Imagine a situation that these contours have been imported from a DWG file, coming from a topographic survey or any topographic data, and we want to use them to create a terrain. The first thing that we need to do is to elevate them according to well, their position in the model, the 3D model, right? I'm gonna work in ghosted mode, so I will have a better performance. And under the terrain modeling tools, we can use this command that will be used to elevate curves according to an interval. I'm gonna set this to 1 meter, and then I will click this button to draw a line, and all the curves that intersect with this line will be elevated according to this value. and taking into account this start dimension, which is 0. When I click apply, you can see now that the curves have been elevated. Okay. So to create a terrain from these curves, they don't need to be planar curves, aligned with the XY plane. I mean, they can be curves in any position. Okay, so it can be a curve like this perfectly. And now I can run the terrain command. When you run any command in RhinoLands, well, you just need to follow the instructions in the command line down there. And it's very easy, very intuitive, to explore all the tools just by, following the instructions indicated here in the command line. Now, I need to select the curves that will be the input data of that terrain. You can also select points, okay, if you like, and also do these 2 curves and hit enter when you're done. We need to specify the cell size of the terrain. Of course, the smaller the cell size, the more accurate the terrain will be according to the input data. Okay, in this case, I will just set 1 meter. And also we can have a base for the terrain. Here under the contour lines tab, we can define the contour interval, which is calculated by default according to the size of the terrain. And we can also enable some index just for the display of the contours in 2D. Also, there is a material assigned. RhinoLands provides a library of textures and for different objects, so you can explore them if you like. But basically, if you are using another render plugin, for example, V-Ray, so you will be able to assign also your materials from other render engines. Okay, so it's totally up to you. Well, in this case, I'm gonna leave this material selected, click OK, and now I have the all-terrain created. Okay, from here I can show this in render display mode just to appreciate the material assigned to that. Well, I can hide already these 2D curves. They were located in a specific layer, so I'm gonna hide them. Because now, if I select the 2D representation, you will see that the terrain is represented with 2D contours. Okay, and actually, I can also show it in 3D and in 2D at the same time. From the general tab of these terrain properties, I can click this button to show the 3D and 2D representation at the same time. Also, I will switch off the base. So I'm gonna disable, so I just keep the top surface. Okay. And also notice that as soon as we have a terrain, all the plants and elements automatically project on top of it. If we move any of these, for example, this jacaranda, we move it to a position just next to this corner, you can appreciate here that the plants is automatically detecting, the topography of this terrain and being placed on their position, on their top. Okay. Right. I would like to show you some of the terrain commands, terrain operations that we can do. First of all, this terrain has taken a kind of a boundary, area that is occupying this part of the park, which is something that we don't want because we already had some zones and there are some overlapping surfaces here. I'm going to show this in wireframe so I can appreciate better the curves that are underneath. And here there is a command, which is the boundary, that lets us define the boundary of the terrain. So I will pick the terrain, and now I will select a curve that I had previously prepared that will be able to use, well, to define a new contour to that terrain. Okay. Right. Now, if I select the terrain, I can see here all the metadata, all the parameters that are stored in it. So on one hand, we have the elevation data. Okay, these are the curves and the points used for creating the terrain. You can see that I can select any of these control points, which are the same as the original curves, and modify the terrain by pulling them or moving them. Okay, but also here we can see the boundary curve that we have used for the terrain boundary, and we can remove this just to recover the original, shape of the terrain. Okay. more operations that we can do on this terrain. If I show this in ghosted display mode, we can see here a curve that we can use to add a path on this terrain. So now we can see here that we have a path command to add a path on this terrain. So after running this command, I'm going to pick the terrain. I will define the width, let's say 3 meters, it's fine. And also an angle for the slope that basically will be how the terrain will meet the boundary of this path, okay? 45 degrees, this is fine. And finally, I select that curve. Okay. Well, just notice that the path has been created according to the elevation of the curve. But if we select the terrain and we go to the earth moving operations, we can select now this path and explore the different options. So as we can see here, the slope method has been taken from this curve elevation. But if we choose instead the terrain elevation, the path will be created kind of projecting that curve on the terrain and trying to fit, with the current terrain topography. But we have more options here. For example, we can create a path according to a regular grade. If we select this option, we can see now that the path is created according to this percentage. Okay, we can define it as a height, also as a raised run, but basically here we can change that slope and have a path according to a regular slope. Of course, this is not the direction I wanted to create. This depends on the curve direction. There are commands here to flip curves in advance, to avoid this wrong result. But also there is here a shortcut to do the same thing. So we'll invert the position of this path, and we'll have it as in the desired position. Okay. Well, since we have created the path and we are already changing the topography, we are already applying some land movement here, we can list it. So we go to the documentation toolbar, and we can add here a terrain list. So this is basically a 2D list that will show the terrain information, showing the total volume of fields and digs according to this operation. Okay, and this is an information that will update at any time that we apply another operation in the terrain. For example, let's see another operation that we can do. I have here a boundary, a rectangle basically, and we can use it to create a cut and fill. So I'm going to elevate it slightly in a way that part of this boundary is outside, another part is inside the terrain. So I'm going to flatten this area according to this curve, which by the way can be sloped. Okay, so it doesn't need to be flat. You can use actually sloped boundaries to create also some sloped sides for the terrain. And now I can use this command, the cut and fill, to flatten this area, just fitting with the position of this curve. So I'm gonna pick the terrain. Again, just following the instructions in the command line, define the slope around that boundary, and finally select this curve. Okay, and we can see here that this has been flattened. Now, if we select this terrain, we can see that the cut and fill operation has been included here. Also, when you add path or cut and fill operations, there is a division also added here, which lets us apply a different material. So here in this case, we can select the cut and fill. And here, each cut and fill, each operation has a related subdivision. This one is the one of the path. This one corresponds to the cut and fill, and here we can assign a different material, if you like. Okay. For example, we can explore this to maybe add some kind of grass on that area. Right. Also through the grid points, we can change the boundary, we can change the position of that boundary and so on. And if we take a look at the terrain list, we can see that the new operation has been added here, and we can quantify now this operation. If we select the list, also we can explore the different options that we have here. We can check and uncheck different fields, okay? And we have also some graphic or aesthetical details, okay? Good. Let's move on. Now that we have a terrain, maybe we can insert more plants here. So I'm gonna work from the top viewport. I'm gonna maybe draw or insert a forest. And from the vegetation toolbar, I click on this forest command. Well, this asks me to select a species. So I'm gonna select maybe the jacarandas, and under the forest tab, define the number of units, the minimum distance, or if we want to insert this in an ordered way in kind of this array option, okay? And now I click OK. I can select maybe a boundary curve. I could select the same curve that I used before, but I don't want to put these plants here. So I'm gonna just select the polyline option here. I will disable these snaps and just draw the boundary where my jacarandas will be placed. I mean, I don't need to close this. I can do right click, so the boundary will unclose automatically. And now I can take a look at this in 3D, and I can see all the jacarandas placed in the corresponding elevation because they are automatically projected on top of the terrain. I can select now the forest. Here I can change the number of units. I can also change the dimensions of these trees. Okay. I can also combine a species in the forest. For example, here I need to define 2 elements. And now I will be able to select one group or another, and well, change the species that I want to have here. Okay, so this way you can create a mix of a species inside the forest. Also, you can define an area to be clear from trees. So I can select that. I can select that the forest. And here, I mean, there is an option to redistribute, because this is a random distribution, but I can select this option, add whole. So I will select that curve, and no plants will be inserted inside this area. Okay. Good. So, well, as we have seen before, we can arrange plants in forests, in shrubs, in plant rows. We can also insert ground covers. Maybe it's something that I can show you here. The ground covers uses different representations of plants, either in 3D or in 2D. In 2D, they are represented as a hatch pattern. But here, when we browse for the plant species, okay, I need to clear this to see all the species that are suitable for ground covers. And, well, I will be able to select that. And these ground covers are represented in a different way than just individual plants. Okay, so I will accept this species, and I will basically select a rectangle here. Okay, to insert a ground cover on that area. This ground cover is as well, again, automatically projected on the terrain. And after selecting it, maybe I can change the scale. Okay.
Or the density.
Or the density, yeah. Okay. Good. All right. We have inserted different plant species, so we can list them in a similar way that we have listed the terrain list. We can add here a plant list. Okay, that is also a dynamic list that will show the information of the plants in the model. Also, here there is an option to add filters. So for example, we can show only the plants in a specific area or in a specific layer. For example, if we select this option and I add a boundary, for example, let's select the same boundary that we use it for trimming the terrain. Okay. Now these plants only show the plants inside the terrain. Okay. So there are different options to filter plants by layer or by region. Also, this list can be exported. Okay. Here there is the option to export that to Excel or XML file. So yeah, you can also have this information in Excel. Now, maybe we can see some of the hardscape tools. Okay, maybe we can add here a row of elements. So, well, RhinoLands includes a library of blocks of block elements that can be included individually or can be arranged also in a row. So with this command, we need to click on the block library to explore the different blocks that we have. Keep in mind that these are nothing but 3DM files, in a folder. If you have your own library of objects with a format that is compatible with RhinoLands, you can also use them. Actually, you can add here like custom shortcuts of your folder where you have your blocks and use them in your model. Okay. In this case, I'm gonna pick any of these lighting objects. Here we can explore different row parameters. For example, I'm gonna insert street light every 8 meters. Okay, and then also I'm gonna use the same path that I used for the terrain path, the same curve, and of course I don't want to have the lights on top of it, so I'm gonna offset this by 2 meters. I select this curve, and now I have also these street lights as well projected on top of the terrain. Okay. Then I can explore the different alignment options if I go to the sample and I align them perpendicular to the axis, or I can change the offset so they are not so close to the path, or we can change maybe the separation to a higher value. So as you can see here, there are different parameters to play with all the details, so they help you to insert the objects as you like. Also, maybe I can show you some of the new features in the last version, which is the ramp object. Okay, so well, we can create ramps according to these parameters. I'm gonna align it to the left because I'm gonna insert a ramp in that part. And then, well, the flight define also the slope of that ramp and the dimensions. So the width will be 1 meter, and the height will be maybe 0.4. So this the slope of this ramp will be defined by the total height. Okay. I click OK, and now I can simply draw a polyline aligned with this. I'm gonna select the snap near, that's fine, and I will insert the ramp in that part. Okay, and we can take a look at this ramp now, and we can see that well, there was this small start. I'm gonna start it from 0, so now it matches with the the start and the ending slabs. Okay, and also in 2D we can show it with a percentage, so we have different also representation modes. Okay, for the ramp in 2D, or show it as an angle or raise ramp. Okay. Now, in this project, there were few zones that I showed at the beginning. We can see them in 2D. These are these areas displayed as a hatch patterns. And this is sometimes some of the first step that we do in the design process, creating all the zones to have an idea of how the different activities or areas will be distributed. So from the documentation toolbar, we can insert a zone with this command. There is the option to pick, an empty area that will detect all the surrounding curves, or select the boundary if this is already created. And a new zone will be created here. I can call this building, imagining that we have a building here. And now I can select the position of the level. And now I can also have a zone list as we did before. Okay, if I select this zone list, I can maybe show also the sample icon. Okay, and maybe I can change the hatch pattern on this zone, so it's maybe not so dark. Okay. Okay, so I can change the scale here to a higher value. Now, just to finish, I would like to show you an example of how to create animation. Okay. On one hand, there is here a nice tool to navigate through the project in walk mode. When we click on this button, RhinoLands puts the camera on top of the zero elevation or on top of a terrain. And now with the mouse cursor, we can, just explore. We can also, with the wheel, change the speed of navigation and explore the project interactively. That's very interesting to have the feeling of how the design goes. Okay. If we hit escape key, we will exit this walk mode. And now if we open the animation panel, here we have also the options to open the different panels if they are closed. We can also create an animation based on these parameters. I would like to also to enable the sun, so we'll have a better feeling of the project, and also how the shadows work according to a day of the year and moment of the day. And back to the animation panel. Here, in order to create animation, we need to define a camera path. So I'm gonna show a camera path that I have in a hidden layer. Okay, this is the curve I want to select as the camera path. So back to this panel, click on this button, select that curve. Now I can hide this curve. So I can actually hide it from the layers, or I will hide it here. But the curve is already assigned, and I can define the animation according to frames per second or from a total duration. And I also have more options to look forward, to look to a target point, and so on. And also, we can choose whether to shot the render, shot the animation according to the current display, which is the rhinoceros display, or according to the render. In this case, a render for each frame of the animation will be created, and at the end we will have a kind of a movie file for the animation recorded. Okay. In this case, just for the preview, I'm going to select the Rhino display, and click on the play button to see how it looked like. So this is a quick way to explore the options to generate animations. And at the end of the day, when we're happy with the result, record it with this option and have a nice result. All right. Maybe we have some time for questions before we finish.
Yes, there are several questions that I prefer to answer at the end because they need to see, well, we need to show them how they work. So the program, the question about how they can add a new plant species in plant database. If you can show us.
Yeah, sure.
Copy an existing one.
If we explore the plant database, I mean, we can access to it when we run any of these commands or directly from this button. We can see here the dialog, and we can click on this button to just create a new species from scratch. Okay. I mean, there is this technical form for the plant species. We can add here all the details, etc. Also here we can assign a 2D crown for the representation of these new species according to a list of 2D crowns that are provided. Of course, you can also include yours. I mean, these are nothing but 3DM files, you know, that you can also create from scratch and use them for the plant representation. And the same for the conceptual shape, the 3D shape, and for the render. Here we can also assign a specific R3 file, the one that, you know, fits better with the real appearance of the plant. Also, there is a plant editor included in the program. According to the different species, you can launch it and create the new plant species from there.
Okay. But I would recommend you to use an existing one and copy that. In this way, you can create a plant much faster. So just copy a similar plant species, maybe from the same genus, and rename it as the species that does not exist. Well, here, can you show us the copy, please? Yeah.
Yeah, I mean, the other option to create a new species is simply by copying the species.
Yeah.
And then you give it a new name, and the same characteristics will be
up here.
Let's call this lemon 2.
So,
and then, yeah, we can go to the properties and
then there's a question about another question which is a little bit similar. It's about the vertical garden. If they want to place some plants on a wall, for example, that is the question.
Yeah, in this case, you can use either, I mean, a vertical curve that will be used as the boundary. I mean, you can use the ground cover or the forest command for that. If we use the ground cover.
No, the forest is better because in the forest we have option to select the plants with vertical representation, right?
All right.
So I would recommend this with the forest.
So as you wish, we select the forest and we browse here for the plant database. That it's true that there is already a pre-list here of plants that are suitable for vertical gardens. And yeah, we can select any of those and select. I mean, this is the one that, I mean, each plant species that are suitable have double representation. So we need to select the one that is better for that. And click OK. And select this curve.
I wanted to share my screen, but maybe later, just to show two things. One is the Learn page. I'm going to share the Learn page also in chat. In case that you are looking for this file to practice by yourself, you can find it in Learn page of our website. And
okay,
here is the
By the way, it's important that the direction of this curve, okay, it's the one that you want, because this will affect, you know, the direction in which the ground cover or the forest in this case is great. Okay, so that's important to take into account.
Then another question is about the BIM information. How will the model information in the model look like when other opens an IFC file, IFC model exported from RhinoLands? Which information they will get?
Well, basically all the all the elements that are in the model are exported as proxies. Okay. So there is not that much information, but there is the option to add custom parameters to the geometry, and this is something that is managed from the options. And there is a section on the RhinoLands options that lets you add custom parameters. For example, here we can add a parameter for price. We select a category, and this could be kind of a currency, right? And now, when we select an element, for example, this wall, from the properties under this icon, we can assign a value to this price. Okay, and this a value that will be stored in that object when we export it to IFC. Okay. In addition, if you have any Rhino geometry, I mean geometry that is not parametric, it's not a plant or a wall or a stair or a ramp, we can tag it with a specific type.
Okay, another question about road intersections, actually. So there's some limitations in road intersections, but
Okay.
Right, but in road, there was another question about managing and controlling a slope of a road. This is something is totally available right now, so you can control a road.
Yeah, let me finish with this detail. So when you have a Rhino geometry, you go to the properties, there is this IFC tag, and you can assign a specific IFC type to that object. Okay, so we can, I don't know, export this as a ramp, if you like, okay, or as any other type that is listed here, which corresponds to product types. Okay. So now, you were asking about options to change the slope of the path. Is that right?
Yeah.
Well, yeah. I mean, we have seen this already. If we go to the terrain, we can see here that path listed, and then we can explore the different options to define the slope of this path, either as a percentage with a specific value, if it's a raise run proportion, okay, or even an angle.
Yeah.
Okay.
Thank you. There's a question about the irrigation system. We didn't show them during the presentation, but there are simple.
Yeah, there are a few tools to insert the sprinkles. Can be individual sprinklers or can be distributed into an array. And later on, you can also add a list of sprinklers. For example, we can add a sprinkler array in this area. Okay, so we select the boundary. We need to select the symbol and different sprinkler types. And I'm gonna select this curve now. And if the sprinklers are too big or the separation is too big, we can change that afterwards, selecting the sprinkler array and editing the properties from the edit panel. Okay.
Okay. Thank you. And the piping, no, can link them automatically.
Yeah, the piping commands are basically 2D lines that can link different sprinklers, and later on, I mean, they are 2D lines with data. Okay, data according to the pressure and diameter, but they just have a 2D representation. It's kind of a simple command, but you can quantify them according to the total length of piping systems, and also as a interesting tool to link sprinklers automatically.
The option to organize a project per sheet templates for project delivery.
Yeah, I mean, at this point, I didn't show that that's true. When we want to prepare the page layout, I mean, the drawings of this project, well, this is handled from the layout where we have details. Details are basically windows to the model space, okay? And then in each detail, we can also, well, set the representation mode, okay? If it's in 2D or 3D, for example, here, the top view, we can show this detail in 2D representation, while here we can show it with elevations. And this is just a rectangle, so I can add maybe a detail here. Go to the documentation, add a new detail.
In the chat, I shared a link to playlist in the meantime that you're explaining.
And show here the, for example, the zone list or the plan list.
Thank you. So good news for new users is that we recently published a new set of video tutorials on our YouTube channel. I'd like to share my screen. Hopefully,
Okay.
I can share it now. So on our YouTube channel, you will see that RhinoLands tutorials. This is a new set of tutorials that you can start from how to start from beginning as a beginner to continue drawing, modeling, terrain tools, hardscape, vegetation, and documentation. Whatever questions that you have about layouts and project delivery is covered in documentation tutorials, but in case that you are missing any questions about any section of the program, just feel free to ask us. You will have a free technical support from our team and unlimited. So feel free to just write down to us any questions that you may have. And I hope you can enjoy this new set of video tutorials here. I'm going also to share the RhinoLands website. Here in download page, you can see that you have the access to free 60-day trial of RhinoLands. So just fill out this form, RhinoLands, and download RhinoLands. And I hope you can have time to practice by yourself as well. Thank you. Thank you, everybody. Just let us know if you have any questions. Feel free to contact us later. Have a nice day. Thank you.
Thank you for attending. Bye-bye.
Bye.